1995 Chevy Astro van with a no start situation. I am told that it has a brand new fuel pump in it, and we still do not have fuel pressure, and we do have spark. So let's verify those first. Okay, fortunately the garage already has the doghouse off of this. So that's the inside cover for the engine. And I have a fuel pressure gauge connected. And let's crank it over and take a look at it. Initial test there with the key on. I did not get a prime of the pump. That'd be the initial 2-second run of the fuel pump. Cranking it now. Okay, as you can see, no fuel pressure. Now there's a few ways that we can handle this. It depends on the equipment that you have. I think for this video, I'm going to try to stay as low tech as possible. And so the first thing would be, let's verify spark, make sure that we have it. And the reason we would question that would be the computer needs to have an RPM signal to run the fuel pump. And if I have spark, that helps me verify whether or not I have an RPM signal. Now, one of the things that should happen though, in spite of the RPM, is when I turn the key off and back on, I'll wait like 5 seconds on key off, key back on, which I just did right now, I should have a prime occur on each key cycle. And what that's suggesting is that we're not really going to be concerned about an RPM signal because the prime should work independent of that.
Well, that was totally horrible description of what I'm trying to get at here. I'm going to, for the next part of this, show you guys how to verify spark and verify pickup coil operation, even though I feel like I don't have to, because the prime isn't working. So with the prime not working, I'm more focused on the relay and the computer control of it than I am spark and anything else. I think it's worth showing you guys this part because a lot of what you're going to run into with this is no RPM signal coming from this module, and what will happen is you'll have no fuel pressure when you're cranking. You will have a prime, but when you crank it, you'll lose pressure and then it'll drop to 0. And so it's really important to know how to address this part. So right now, what I'm checking for first is I'm checking for spark coming from this distributor. If I have spark, that tells me my pickup coil signal is good and tells me that my ignition module is good. Now the module can fail in 2 ways. We can actually have a module that doesn't give us spark, and we can have a module that doesn't give us injection pulse. So you'll watch here, I'm cranking it, and you see I have spark, so that tells me that my pickup coil signal is fine. And my next step now is to make sure that that pickup coil signal gets converted on this purple white wire that I'm going to point out to you here in a second. You can actually see the yellow lead that I'm connecting to the distributor is already on that purple white wire. That's what I'm pointing out right now. So I'm going to wait for a second. I'm going to pull that lead out and show it to you. And I'm describing this right now, that this pickup coil signal, it's analog, gets converted to digital, and it gets sent out on this purple white wire that my yellow lead's connected to. And just because I have spark doesn't mean that signal's getting to the computer, the pickup coil signal. So that's what I'm verifying next. And I'm using a old school Vantage Pro to do that, to show you this square wave. And I apologize for doing it this way, guys. I just was rambling a lot in the first part of this, and it was horrible. All right, so this signal here is going to tell me everything I need to know about the distributor and the module itself. Is this module creating the signal that it should be from this pickup coil? Just set my scales up on a graphing meter, 14 volt, 5-second screen. And when I crank this, we want to see an on-off signal. There it is right there. I'm cranking the engine over. You see my on-off signal. So what that means is I should be getting an RPM signal to the engine computer, and I should have fuel pressure, and I don't. So that's strike two for us, really. Number one, the prime doesn't work, and number two, the RPM input isn't working either to the computer, or it's working from the distributor, but is it getting to the computer is a question. So really what we're doing here is verifying the distributor side, and now we're going to have to go to the relay, do some checks on the relay, make sure the computer's good. All the steps that I just showed here, really, I didn't need to do for this particular case study. I think it was important to show you these steps because there's a lot of problems with these distributors, and again, you can have no fuel pressure, no injection pulse from a faulty module, and I just showed you the steps involved in testing it. Now the next part, I'm going to show you a test without the scope using a test light, and I'm going to pick it up from there, I believe, with the regular video.
There's another way that we can do this, and it's using an incandescent light, but what we would do in this case, if we can't test that signal on the purple white, we can create that signal with a test light, and we can make the computer receive an RPM signal, which would turn the fuel pump relay on and fire the injectors. So the method for that is taking your test light to the battery positive. Okay, I have my test light rigged up to battery positive. As you see, the test light lights when I touch ground, and I'm gonna back probe this purple white wire again. I know this is low in the shot here, but I'm not using a mount for my camera, so you have to forgive that. All right, with the key on, this is important, the key needs to be on. What you would do is you touch on and off this wire. And listen, I actually heard the coil fire when I did that. Listen again. So what I'm doing is I'm creating the signal the computer needs to fire the injectors. I'm actually making the coil fire too. And what we should be seeing when we do this is we should be seeing fuel pressure increase on the gauge. Okay, just a quick way to verify that our RPM signal is being created for the engine computer to run the pump. So we're definitely going after the pump now, not worried about the distributor anymore. Again, the prime also told us that we had a pump issue, but I don't always rely on the prime. Not all cars give us that. So the prime would be key off. You want to wait 5 seconds for each time you turn the key off. The computer takes a few seconds to power down and will not turn the pump back on immediately if you keep cycling the key. Turn the key back on. I just did. There's no prime. I don't hear the pump. The relay is under the hood, so I can't hear or tell if the relay is functional or not. But we definitely are going after the pump circuit itself now. And what we've done so far, just to review, is we have verified the pickup coil, we've verified the conversion from the module, and we've verified that the computer is receiving that signal.
We actually have not verified the computer's receiving that signal. All we've done is checked it at the distributor. What verifies the computer's receiving that signal would be if we had injection pulse, and I can't hear the injector firing because it lives under the manifold and it's being masked by the sound of the spark. So we haven't confirmed 100% yet that that signal's made it to the ECM. We're going to the relay to do some checks there next, and then if we have to, we'll come back to that.
Okay, there's a few things we can do for this next part. One is to turn the key on, have somebody turn the key on, and then feel for the relay to click. The relay that we're going to be testing is this one. We can actually see some evidence that someone was here. A little poke in this gray wire right here. What you're looking for, pretty standard on GMs, is a relay that has a heavy gauge gray wire going to it, and then also one of the other standard colors is a green with is a green with a white tracer, which is on the other side. So you see a relay with a heavy gray and a green white, that's your fuel pump relay. Tim, can you just turn the key off and then back on for me? Sure. Just gonna listen for this relay to click. Turn the key off and wait 5 seconds, then turn it back on. Nothing. No click at all. Okay, a couple of quick checks on this relay is the heavy orange wire should be hot either all the time or with the key on. I got nothing on that. Turn the key on. Okay, I need to make sure that my test light has power. Or sorry, has a good ground. And it does. So there was no power on the orange. Going after the green with the white. This one should be power when we turn the key on for 2 seconds. This will be the prime. Turn the key off, wait 5 seconds, then turn it back on. Nothing. That is not what I expected to see. Okay, some unexpecteds with this relay, guys. I'm gonna come back to this relay. It looks like I either have an issue with my test light not making contact, or I absolutely have some power issues here. But what I wanna do next, because I was concerned about still not having pressure when I did this before, on some of these GMs, they give you this wire that breaks out of the harness, usually near the relay. What you can do, you can jump direct battery voltage to this, and so that's what I'm going to do. And what that does is runs power right back to the fuel pump. Okay, just a jumper wire, and I do have a PTC resistor in here. Basically, it's a fuse that resets itself in case it's shorted to ground. And what I'm looking for here is actually a little bit of an arc. Pretty decent arc, actually. I don't really want that occurring at the battery. Should have done that on the other side. Arcing next to the battery is not a good thing. So now that I have power there, I'll show you the arc over here. This is a better test, away from the battery. See, the arcing is telling me that I'm running my pump. Now, how much current? I'm not sure. Do we have pressure? I'm not sure. Let's go inside and take a look. Okay, I can hear the pump running, and we're at about 64 PSI, 62 maybe, which is pretty good for this system. Crank it over. It should start as long as there's no other problems. But given I didn't have power coming from the computer for the fuel pump relay, concerns me that the computer's not alive on this. It wants to run. I'm gonna give this a little bit of gas. It's got a little bit of a misfire to it. I can hear some arcing going on inside that distributor cap. All right, well, the lack of it idling is a separate issue. You see we have fuel pressure with that jumped. Why don't we have pressure whenever this vehicle is being cranked or with it running off of the relay. We need to go back up front to the relay. All right, one of the things about having this jumped like we do is we're bypassing the relay. So we need to come back and do our checks on this relay again. My test light has a good ground. This orange wire on this relay, without looking at a diagram, this orange wire should be hot pretty much all the time, and it is not. And then I have the key on right now. This green and white, that's the computer's control wire for the relay. Can you crank this for me, Tim? That should light up when he cranks this. I was relying on the prime before. All right, okay. I'm thinking my pin is not long enough. Try that unplugged. I don't think I'm making contact back probing this. So the green white wire, that's the computer's control. This test light I am not stuffing into the female terminal. I'm going to put it next to it because I don't want to spread the terminal. Just going to hold it there. Hey Ed, can you crank this for me? This wire should give us our prime and light up when we crank it. Okay. Yeah, that's not working at all. What that's telling me is like the computer's not turning this relay on and not receiving an RPM signal, but I know it is because it runs. Something's wrong with this whole harness. That should be lit right now. So I'm missing two things. One, I'm missing the main power to this, and I'm also missing the computer's control of this relay. And those two things are two completely separate circuits. I need to look at a diagram. All right, sorry about the glare on the screen here, guys. This diagram, if you look at this orange wire down here at the bottom, that orange wire, I don't have power there. And I also don't have power on my dark green and white when I crank it, which is contradictory to a few things. One, with no dark green and white wire power, that's the computer's power to the relay. What that suggests is the computer's not receiving an RPM signal. But the car runs. So I know it's receiving the RPM signal. So why isn't it turning that on? And I think to address the dark green white wire, we need to address the orange wire first. The orange wire is the main feed. That should be there. It's not. When I'm jumping the pump, what I'm doing is I'm jumping, this wire is not red on the car. It's actually gray. I'm jumping this, the normally closed contact in the relay. Actually, this is a little bit off here. This is not a 5-pin relay, it's a 4-pin. So that's tied into this gray wire outside of the relay. And then what it does is it runs straight over to the pump and runs the fuel pump, bypassing the relay completely. So because I can run the car with power going to the pump, that tells me the computer has an RPM signal because it wouldn't be able to fire the injectors without it. The dark green white wire, the computer again powers the control side of the relay. The orange wire, if you follow the hand here, splits, goes the oil pressure switch. It actually goes to the ECU right here, the orange wire here. Follow the hand. Goes up to this splice right here. And then there's a dotted line, so it feeds other circuits too. And it's the ECM BAT fuse. It's a 15 amp and it's in the fuse block behind the left side of the dash. So that's the first thing I need to check on this, is that fuse could be blown. And it is possible that the old pump went bad and blew that fuse, and then really all we needed this whole time was a fuse. I'm gonna be a little bit disappointed if it's a blown fuse and that's all we need. Let's go see. There's an ECM 10 amp and that one's good. This ECM B fuse
Got nothing on that one. And nothing on that one. So that whole circuit is dead. Okay, so we need to find out where this is getting power. It'd be a fusible link under the hood. All right, so what I need to do now, this is hot all the time. I need to find out where this gets its power from. There's gonna be a fusible link. This ECM bat fuse on my van, it said ECM-B and it was dead. And I got a little other piece of information here, and that was something with the headlights. He was having issues with the headlights too. When everything shut down on him. So I don't know, we got to find out where this is getting power. It might be related. Here's what I'm thinking as far as that green white wire goes and the RPM signal. And some of you are thinking, well, how's it even running with the computer being partially dead? So this 12 volt feed coming in right here powers the computer. And the short answer would be there are other power feeds this computer has that it clearly can run with. But I think when I restore this power on this orange wire, I'll get my fuel pump relay control side back on this dark green and white. I absolutely believe they're connected. So what I need to do now, I think I'll be able to on this year, is I need to find my power distribution where it powers this up. So we go power distribution. And what I'm looking for, there's my ECM-B fuse. Looks like the cigarette lighter, horn maybe, that's the horn circuit, the daytime running lamp fuse, nope, these three, sorry. The cigarette lighter, the horn, and TLLPS, what is that? See. Just want to see if that is related to the lighting. He had mentioned the lighting. The headlight switch. Hey, he did say the headlights crapped out on him at the same time. I bet you that fuse is dead. The ECM-B fuse, that feeds my PCM. It feeds the fuel pump relay. Right, we knew that. It feeds the oil pressure switch. We knew that. This is just a little bit different layout of a diagram. So following that, it goes to a red wire and a splice. It's feeding other fuses and other circuitry, but this fusible link's the one I'm worried about. There is a battery junction block. Where is that battery junction block? I need to find that. I'm worried about this fusible link right here. And it does feed the headlight switch. All right, let's go find that on the car. Back here. It's back here behind the battery. All right, I'll keep you guys zoomed out here. I put my test light back over here on the relay. And when I wiggle this connection back here, that light should come on as long as I'm making contact. Kind of keep an eye on it there for a minute. Just tugging gently on these fusible links. None of them are blown. All right, let's get you a shot of this. It's melted. This is an example, guys, of what happens with bad contacts. This is melted. You see the front face of it. Pretty sure that's showing up on the camera. Okay, so that probably was not making contact anymore. The reason they melt is from poor contact. It would not be from a faulty pump. A lot of people think, oh, that's too much amperage causes that. No, not in that location. That is from corrosion, and corrosion equals heat, and we'll do exactly that. I just plugged it back in, okay? Check it out. Our circuit is lit. So without the fuel pump connector being jumped now, as you can see, we should be able to run this car. That might actually explain why it wouldn't idle too, you know, with half the computer being dead. Let's see if that stays lit and the vehicle starts. That is idling on its own. Show you guys something else here. This would be my green wire. Okay, that's the circuit. That's gonna give me my prime. That's the one the computer's energizing to power that up. So watch it. This is with the key off. I turn the key on, we should get a 2-second prime, and then it will shut back off. As you can see, that was my prime. So my whole problem is this little power box it plugs into. This is one of those things, I don't know the exact name of this component, but what we need to replace is this guy right here. So it's got a connector and then a main power that comes in right here. It's a little power distribution center. And again, poor contact. This piece needs to be replaced. It looks like it's bolted in. Not sure exactly how, but we need to replace this component. There is no fixing that. And really what it's going to need also is it's going to need this terminal replaced, this whole connector replaced, because of this is melted here on the end. So that was killing power to our relay. That was actually killing power to the fuse inside on the fuse box, which was also tied in with the headlights. So it explains why the headlights quit working at the same time. And then you also saw that the computer's control of the relay, with half the computer being dead, it wasn't powering that circuit up. So yeah, that's it. Hopefully the equipment I used was low tech enough for you guys to follow along. I think there were some lessons learned for sure on this one. Sorry about the mic difference. I'm using the camera mic right now. Instead of replacing this part, which we're not gonna be able to find, what I did is I unbolted the unit, which is actually part of the battery cable. Where's it at? Hanging right here. It's actually part of the positive terminal of the battery. And what we're doing is we cut that wire out of there. We're gonna use this same junction, put that on there, put this over top of it. And by the way, we're still using the fusible link, so we're still protected. This eyelet here is going to be my positive. A little bit big of an eyelet, but it'll be okay.
The washer behind it?
I don't think we need, yeah, maybe. Maybe we go on the front side. No, hey, I'm gonna go on the front side. This eyelet's a little bit bigger than I hoped for. So what I'm gonna do is bolt this back up. Okay, so you can see I changed that up there. That eyelet was a little bit big for the back side, so I'm going on the front side, and that'll take care of the bad pin. That'll take care of the
connector itself. The other 3 look good, so that's the way we're gonna fix this. I'm gonna call that a permanent fix. Good luck finding the actual part for this on a 1995 vehicle. So that's the way we're doing it. And I'll just let you get one last shot of hearing the engine run when we're done. Hold on 1 second. Turn your key on. Good. Awesome. Okay, turn those headlights on again. Okay, good. Headlights are nice and bright too. All right, that's a fix.